Welcome back, guys. It's Miss Bauer again. So instead of doing cubic functions, today we're going to talk about cube root functions. So what's the inverse of the cubic parent function, which is just y equals x cubed? The opposite of cubing something is cube rooting something. So that would just be y equals the cube root of x. So if you remember from the other day, cubic parent function was y equals x cubed, and it was like this. A little bit off there, but like that. And it was -2, -8, -1, -1, 0, 0, 1, 1, 2, 8. Well, now we're doing the opposite. So it's not going to go down, up. It's actually going to go left, right. So instead of, it was -3, -27. Now it's -27, -3, -8, -2, -1, -1, 0, 0, 1, 1, 8, 2, 27, 3. Because it's the inverse of the cubic parent function. So graphing this, -27 is way off of our graph, but so -8, -2 would go right here. -1, -1 would be right there. 0, 0, and then 1, 1 would go right there, and then 8, 2. So just like that. And then identifying all of our key features. So TP, or turning point. Hopefully you do still have enough toilet paper. I'm getting worried my supply's a little low. I'll be fine. So turning point 0, 0. It has rotational symmetry, because remember it kind of turns around that way. It's not symmetrical like you fold it. It's symmetrical like it rotates. So it has rotational symmetry around our turning point at 0, 0. My domain and my range are still exactly what they were the other day, because if you think about it, if the domain was -infinity to +infinity, that becomes the range. Well, the range was also -infinity to positive. If I just swap, it doesn't matter. It's always -infinity to +infinity. Our x-intercept is still 0, 0. Our y-intercept is also 0, 0. Now I just need to figure out my maximum and minimum from -8 to 12. So -8 starts here, and 12 would go off my graph over there. So if I plug in -8, that's going to give me my minimum, and if I plug in 12, that's going to give me my maximum. Well, if I plug in -8, I know I'm already going to get -2, so that was my minimum. To get my maximum, I'm just going to plug in 12. So I need to figure out what's the cubic root of 12, which as a decimal, I don't know what that is because I don't have a calculator in front of me, but you can just leave your answer like that and just say the cubic root of 12, and that's acceptable. So now we're going to graph another one. So now we're going to graph -2x to the 1/3 plus 4. That 1/3 is just this. It's just the cubic root. It's just -2 the cubic root of x. It's not this. That's not inside the cubic root. It's just on the x part. If it were this, then that would be in parentheses. Just a little kind of side note. Anyways, so that's just like saying this right here. So that +4 on the outside means it's going to go up 4. And then that -2 means that instead of doing this action, it's going to go this way, which I'm somehow even worse at drawing. So I'm just going to go back to my little chart. So -8, -2, -1, -1, 0, 0, 1, 1, +8, 2. I don't know why my Apple Pencil's being weird. But now all of these values are going to double. So that would become 4, 2, 0, 2, 4. And then that negative means they swap. So the negatives become the positives, and the positives become the negative. Remember, I like to think of it, instead of doing that, it's now going to go this way. So I'm going to start at my turning point, 0, 4, and then I'm going to go over 1, 2, over 8, 4, over 8, down 4. And the opposite way, so then I'm going to go left 1, up 2. And then from here, I'm going to go left 8, up 4. I'm way off. I'm way up too high. There we go. So there we go. Right there. And then it kind of makes this curve, which, like I said, I'm really bad at drawing these. Ooh. Good enough for now. Okay, so domain and range, still exactly the same on every single one of these problems, negative infinity to infinity. It has a turning point at, it went up 4, so 0, 4. It has rotational symmetry at 0, 4. And if you feel like I'm going too fast, just pause it or just go back and rewatch it later. My x-intercept I can see is at 7, 0, 8, 0. Don't know why I can't write or talk tonight. So my x-intercept is at 8, 0. Ooh. Sorry, y'all. My y-intercept is at 0, 4. Same as my turning point. How does it compare to our parent function? Well, the negative reflects over the x-axis. The 2 made it vertically stretched. And the plus 4 on the outside just translates it up 4. And now it gives me this interval from negative 1, which would be right there, all the way to 64. So if I plug in negative 1, it's going to give me the maximum, and if I plug in 64, it's going to give me the minimum, which is way off of my graph. If you can kind of tell, negative 1, 6 is that point right there. So there's your maximum, 6. Now to just get your minimum, I'm going to plug 64 back into my original function. So I need to figure out what's negative 2 times the cubic root of 64 plus 4. So the cubic root of 64, you can go to a calculator if you need to and type it in. It's just 4. So it's saying what's negative 2 times 4, which is negative 8, plus 4. Negative 8 plus 4 is negative 4. So my minimum is negative 4. And again, you feel free to go to Desmos or go to some graphing calculator online and graph these and just double check it. So the next one, the function y equals 2 cubic root x plus 1 plus 4 models the monthly profit in thousands of dollars after a cafe is open for business. What's the graph of the function? So I'm just going to kind of see without even looking at my graph yet. I'm going to ask myself, what's the starting point or my turning point? So my turning point, the plus 1 on the inside actually moves it left 1, and this moves it up 4. So that'd be negative 1, 4. And that 2 is going to vertically stretch it. So it's going to translate left 1 up 4, and it's going to be vertically stretched. So if you can look at your graph, if I go left 1 up 4, that's right there. That's off my graph. So just ask yourself, plug in 0 and see what you get, because that's where my graph starts. So if I plug in 0, we're talking about profit for a cafe. Hopefully it's not negative. Unfortunately, a lot of companies are right now. But if I plug in 0, I'll have 2 times the cubic root of 0 plus 1 plus 4. So that'd be the cubic root of 0 plus 1 is 1. So that'd be 2 times 1 plus 4. So 2 plus 4 is 6. So it's actually going to start right up here. And from there, that's what you can do if you want to, is you can just plug in numbers to get the rest of this graph, or you can go back to your table. So we've already done the 1, 1 part, and you can kind of go from there. If I were you, from this is good, you can just kind of sketch it out or go to Desmos and finish graphing it. And that's basically how you graph cube root functions.